Hello everyone, it's Chris. In this video, I'm going to demonstrate logistic regression, but not just in general. It's going to be how it can be used for making much better quality decisions, superior decisions. Logistic regression is binary and it predicts probability, which makes it perfect for finding the correct weights for an expected value calculation. So what I'm going to do is I'm going to imagine a bet that a dog will run versus walk or respond to nothing. So will the dog run, yes or no? That's binary. And we're going to put together a bet, so to speak, with a reward and a penalty. And we're going to train a logistic regression model on some training data and make some observations and a prediction. So let's look at the data that I'm going to use. I'm going to bet on whether or not a dog will run. It's overly simple, but it will work. And it's going to provide some interesting observations about logistic regression. Now let's look at the data. So our first predictor is whether or not we give the dog a treat. And our second predictor is whether or not we're going to give the dog a ball or throw the ball or whatever. And our Y output is going to be run or not. So this is all ones and zeros. And I'm going to generate 1,000 data points. Basically, they're going to be 0 or 1. And we're just going to train on that random data is what we're going to do. So here's a look at that. Treat or no treat. You can see this is all zeros and ones. Ball or not, all zeros and ones. And output, whether or not the dog ran, is going to be zeros and ones as well. Now moving on to model training. So what we do is we train the model on the features treat or not and ball or not, and we need to validate that model. And we get our first interesting observation here about this model. This model is guessing. It's guessing, doing about as good as it could ever do. This score here of 0.25, well, very close to 0.25, means that this model cannot possibly do any better than a good educated guess. This model is not a bad model. It's a very honest model. And what it is everything from our data is 50-50. So ones and zeros, each one of these is random. Everything's a 50% chance. So the best this model could ever do is guess. And that's exactly what it's doing because there's no pattern there. So this isn't a bad model. This is actually an excellent model, and it's telling us the truth. It is saying, I can guess as good as you can, or my guess is as good as yours. Now we can use this model, and we're going to put some new data in to make a prediction. So if I don't give the dog a treat and I don't give the dog a ball or throw the ball, what prediction are we going to get? And the model prediction with this new data happens here. And what we see is there is a 48.9, etc. chance of failure and 51 point blah, 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 blah chance of success if you multiply those by 100. So let's say 49 and 51 is basically what we get. And our Breyer score here still showing 0.249-ish. That means it's guessing, and we can see the probability of success is about 51%. It's 50-50. The model's guessing. So we have a rock solid model here that we're training on data that doesn't have any real pattern. So if we were looking at a line graph and it just looked like a barcode, it's just noisy, it looks like an EKG, there's really no way to predict anything off of that. We would see very similar results here. Now let's take these weights because they are usable. This model is a good model, and let's apply it to the bet. If we bet, or if I bet $100 that the dog will run, the reward is I'll gain $50, but if the dog does not run, I would lose my $100. Is that a good bet? And we apply our weights and make the calculation, and we see that the expected value of that decision is -23. So no, it is not a good bet. It is not worth taking that risk. This same exact idea can be applied to investing, which is getting into quantitative finance. It can be applied to business applications. if I spend X dollars on advertising and this much foot traffic and blah, 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 those data points will have patterns. So when we look at this, where did I leave it at? When we look at this, we're not just going to see zeros and ones for that. So patterns can emerge, and a rock solid model can help make a prediction. Now, it doesn't predict yes or no, it predicts probabilities. That's what the value of this is. And those probabilities can be used for weighted reward and weighted risk calculations. So there is a demonstration of logistic regression.